Hello everyone, myself Vikas is Kumar and I'm studying in Sri Venkateswara College of Engineering. In this video, we are going to learn about design and implementation of microprocessors. Introduction. A microprocessor is a compact and integrated circuit that serves as the central processing unit of a computer or an electronic system. It is designed to execute a set of instructions stored in memory, manipulating data according to those instructions to perform various tasks. Microprocessors are the core components in a wide range of devices from personal computers and smartphones to embedded systems and applications. Key characteristics of microprocessor: processing power, programmability, integration, clock speed, instruction set. Architecture of microprocessors. First, central processing unit (CPU), instruction set architecture (ISA), memory hierarchy, data flow, bus system, pipelining and parallelism, clock and timing, power management, pipeline hazards and optimization. Central processing unit (CPU). First, arithmetic logical unit, also known as ALU, responsible for performing arithmetic and logical operations on data. B. Registers, small fast storage location within the CPU used for temporary data storage and quick access during the processing. Control unit manages the execution of instructions, controls the flow of data between CPU and other parts of the system, and generates control signals. Instruction registers (IR) holds the current instruction being executed. Programming counter (PC) keeps the track of memory address of a next instruction to be fetched. Instruction set architecture (ISA). OP code, the part of instruction that specifies operation to be performed. Operands, data on which the operations is performed. Addressing modes, specify how operands are located in memory or registers. Data movement instruction transfers data between register and memory. Control transfer instruction alter the sequence of program execution. Memory hierarchy registers fast small size storage directly accessible by CPU. Cache memory high speed memory that stores frequently accessed data to reduce latency of memory access. Main memory tab large slower memory used for storing data and instructions during program execution. Secondary storage data hard drives and SSDs. Non-volatile storage for long-term data retention. Data flow. First, fetch, decode, execution cycle. The fundamental cycle in which the CPU fetches an instruction, decodes it, and executes it. Pipeline divides the instruction execution into stages to allow parallel processing. Sorry, superscalar architect allows multiple execution units to operate simultaneously, enhancing the performance. Bus system data bus transfers data between the CPU and memory or other devices. B. Bus address bus carries the memory address from CPU to specific location of the data. Control bus transmits control signals for coordinating various operations. Pipelining and parallelism. Instruction pipelining breaks down the instructions executions into stages to improve the output. Parallel processing, simultaneously execution of multiple instructions or tasks. Clock and timing, a clock speed, the frequency at which the processor executes the instruction. Clock cycles, basic unit of time for processor's operation. Power management, a dynamic voltage and frequency scaling (DVFS), adjusts the voltage and frequency of a processor to save power when the performance is not required. Pipelining hazards and optimization. Data hazards. Conflicts in assessing data. Controls hazards. Conflicts in determining the next instruction to execute. C. Instruction level parallelism. Techniques to minimize parallel execution of instructions. Register transfer level design. Engineers start by designing the microprocessor's functionality using a hardware description language like Verilog or VHDL. This description, known as RTL code, captures the behavior of microprocessor at register transfer level. Simulation and verification. The RTL code is simulated using a specialized tools to ensure that it behaves as expected. This step involves testing the microprocessor's functionality under various conditions to identify and fix any design issues. Synthesize. The RTL code is synthesized to convert the high-level description into netlist, which is representation of design in terms of logic gates and flip-flops. This process is performed using synthesis tools that optimize the design for factors like performance, power, and area. Physical design. In this step, the physical layout of microprocessor is planned. This includes floor planning, which determines the placement of different components on the chip, and routing, which involves connecting these components with wires. Tools such as place and route tools are used in this stage. Time closure. Engineers analyze and optimize the design to ensure the timing requirements are met. This involves adjusting the placement and routing to achieve the desired clock speed. Mask generation. The layout information of physical design is used to create masks. Masks are used in the semiconductor fabrication process to define the pattern for various layers of the microprocessors. Wafer fabrication. These masks are used in semiconductor fabrication facility to manufacture the microprocessor on a silicon wafer. This involves a series of photolithography, attaching, and deposition processes. Testing. The fabricated chips undergo testing to identify and eliminate defects. This includes functionality testing to ensure that the microprocessor behaves as expected and may involve the use of automatic test equipment. Packaging. The tested microprocessor chips are packaged to protect them and facilitate their integration into electronic systems. The packaging also provides the necessary electronic connections for the chip. Integration. The packaged microprocessor is integrated into larger systems such as printed circuit board (PCBs). This may involve designing the system architect, including memory, peripherals, and the interfaces. Documentation and release. Comprehensive documentation, including datasheets and application notes, is created to provide information about microprocessors. This microprocessor is then released for production and distribution. How it works in simple terms. Fetch. The CPU fetches gets an instruction from a memory. The instruction is command telling the CPU to what to do. Second, decode. The control unit decodes and understands the instructions. It figures out what operation needs to be performed. Execution. The ALU executes the operation. This could be a calculation or a decision making process. Store or retrieve. The results are stored back in memory or sent to output devices if needed. The CPU retrieves the data from the memory for the next instruction. Applications. Microprocessors are found in various electronic devices, including but not limited to personal computers, servers, laptops and tablets, smartphones, embedded system, gaming consoles. Thank you.